Output Feedback Mode, OFB. OFB, that is Output Feedback Mode, is extremely similar to Cipher Feedback Mode CFB. The only difference is that in the case of CFB, the ciphertext is fed into the next stage of encryption process, and in the case of OFB, the output of the initialization vector encryption process is fed into the next stage of encryption process. Let us begin with the encryption process. First and foremost, we will have the initialization vector, which is in 64 bits. So, what is an initialization vector? An initialization vector is a random number used in combination with a secret key as a means to encrypt data. Now, we will have a secret key. This key here will also be in 64 bits. This secret key will then be used to encrypt the initialization vector following the data encryption standard, DES, to produce an encrypted initialization vector of 64 bits. Moving forward to the process of encryption, the encryption initialization vector will now perform XOR operation with the plain text, which is in 64 bits as well, to produce ciphertext of 64 bits. In case you are wondering how the XOR operation looks like, you can refer to the truth table on your screen. Now, we have reached to the final step of the encryption process. What happens now is that the encrypted initialization vector will be fed into the next encryption process. For the next encryption process, a new initialization vector will be formed based on the previous encrypted initialization vector. This new initialization vector will then be encrypted with the key to produce another new encrypted initialization vector, which then be used to perform XOR operation with the plain text to produce the ciphertext. Once again, the encrypted initialization vector will then be fed into the next cycle or process. This process will continue until all the plain text is encrypted into ciphertext. Now, let us move on to the decryption process. The decryption process of OFB is actually very similar to the encryption process. First and foremost, we will need the initialization vector, which is in 64 bits. Then, the initialization vector will be encrypted with the key to produce the encrypted initialization vector of 64 bits following the data encryption standard, DES. Now, the encrypted initialization vector will perform the XOR operation with the ciphertext to produce the plain text, which will be in 64 bits. Notice the difference here. In the encryption process, the initialization vector will perform the XOR operation with the plain text, but for the decryption process, the initialization vector will instead perform the XOR operation with the ciphertext to produce plain text. As for the final step of the decryption process, once again, the encrypted initialization vector will be fed into the next decryption cycle or process to produce a new initialization vector. The new initialization vector will once again be encrypted with a key to produce another new encrypted initialization vector, which will then perform XOR operation with the ciphertext to produce the plain text. This process will once again continue until all the ciphertext is turned into plain text. I now hope you will have a better understanding of the encryption and decryption process of Output Feedback Mode, OFB. Thank you for watching.